Welcome back to our series on Learjet systems and maintenance. In this video, we're focusing on two systems vital for flight safety and communication, especially during low light conditions: the navigation lights and the static discharge wicks. First, let's identify the navigation lights. These are standard on all aircraft and are mandatory for flight at night. On the Learjet, you'll find three primary lights: a red light on the aircraft's left wingtip, a green light on the right wingtip, and a white light on the tail or empennage. In addition to these, many aircraft also have anti-collision beacons or strobe lights. But the red, green, and white lights are the key to understanding an aircraft's orientation in the dark. Next, we have the static discharge wicks. These are thin conductive rods typically found on the trailing edges of the wings, ailerons, elevators, and rudder. They may look small and simple, but they serve a critical purpose in managing the aircraft's electrical environment. The number and placement of these wicks are specifically engineered to safely dissipate static electricity that builds up during flight. The navigation lights are a simple electrical system. They are turned on or off from the cockpit. Their strategic color and placement are an international standard for pilot-to-pilot communication. If you see a red light on your right and a green light on your left, you know the aircraft is flying toward you. The static discharge wicks work passively. As the aircraft flies through the air, friction between the fuselage and atmospheric particles causes a large static electrical charge to build up on the airframe. The wicks provide a path of least resistance for this charge to bleed off into the atmosphere. Without them, the static charge could interfere with radio communication, GPS, and other avionics, creating a safety hazard. Both of these systems are in place for one reason: safety. Navigation lights are a primary tool for collision avoidance during nighttime flight, allowing pilots to instantly determine the position and direction of other aircraft. The static wicks are essential for avionics reliability. By preventing a buildup of static charge, they ensure clear radio communication and accurate navigation data. Interference from static electricity can lead to a phenomenon known as St. Elmo's fire and cause significant radio noise, making it difficult for pilots to communicate with air traffic control or each other. Now, let's cover the basic maintenance checks for these systems that are part of a routine walk-around inspection. For navigation lights, the check is straightforward. First, visually inspect the lens cover for any cracks, damage, or hazing that could reduce light output. Then, with power on, confirm that all lights, red, green, and white, illuminate correctly. A burned-out bulb is a common maintenance item that must be addressed. For the static discharge wicks, conduct a thorough visual check. You're looking for any missing, broken, or bent wicks. A static wick should be straight, intact, and securely mounted. A missing or damaged wick can reduce the aircraft's ability to discharge static, leading to the problems we discussed. Count the wicks and check them all. If you find a crack in a light lens, a light that doesn't work, or a damaged static wick, it must be reported to a certified mechanic. These simple, routine checks are crucial for ensuring the aircraft is visible and its communication systems are reliable. And that concludes our video on the navigation lights and static discharge systems. Their combined function is vital for ensuring the Learjet is both seen by others and capable of clear communication, day or night. Be sure to scan the QR code for more detailed information. See you next time.